This is a production of Cornell University.
So this is the topic for today. I'm going to do a project overview. I'm going to talk about the scope. Then I'm going to quickly talk about our inventory results, our mitigation results, our future scenario results, and then we'll move on from there. Okay. We had three major tasks for this project. To establish an inventory baseline of New York State greenhouse gas emissions from 1990 to 2020. We used the IPCC 2019 refinement of the 2006 IPCC methodology, and I see John Duxbury is in the back, and just so you all know, he participated in the development of this methodology. We should all recognize the wealth of knowledge in this room, and he's actually where this all started for me. We follow the AFULU, I'm putting this in here so you all know the term, agriculture, forestry, and other land use. I'll use it. So structure, right? And what's really important about the IPCC methodology is it breaks things apart so that there's not double accounting. And I really think it's a brilliant organizational structure, even though sometimes working in it can feel funky, right? Because you're having to remove things or include things, but they're counted elsewhere. The next thing we did was we worked on identifying key opportunities to reduce greenhouse gas emissions from agriculture. But notably, we constrained these opportunities for the Climate Leadership and Community Protection Act 2019 legislation, right? There's some real guidance for all sectors. And we tried very hard to honor that guidance. And then we developed three future scenarios of greenhouse gas mitigation, a business as usual to forecast trends from the baseline to 2050, a medium scenario, and a high scenario, which is the maximum feasible that we thought was possible. I'm going to skip the medium scenario for time today. This is basically the summary result. The black dots show the inventory, right, based on data. The red dots show the projection as the business as usual into the future. The yellow dashes are for the medium mitigation scenario, and the green line is the high mitigation scenario. Now I want to put us in some context, right? Agriculture is this orange section, right? This is the energy sector. So just realize that what we're talking about today is just 6% of our emissions at the state. As we think about how we want to manage our state, we need to think in size of opportunity and context. This is roughly where the 2030 goal would be, right? 45% below 1990 levels. And the 2050 goal is 85% below 1990 levels and net neutral, right? So we also have to counterbalance those emissions in some other way. Oh, and you'll see, right, that we're on a downward trend. Like, we are making progress, but mostly it's coming from the transportation and the electricity sector. Okay, so the scope of the analysis. This is impossible to read, but this is the AFULU structure, right? And this is how they're breaking out all of the different components of the accounting framework. In the simplest terms, 3A represents livestock, animals plus their manure. 3B represents land use, and 3C represents land management, like lime, urea, and nitrogen. 3C also has forestry, but we're not doing forestry. Colleagues at Syracuse are working on that component. We have an afforestation component, but that is a new initiative, not existing forests. The AFULU counting mechanisms, there are three tiers. Tier 1 is state-specific data plus default factors. Tier 2 is Tier 1 plus state-specific factors. And Tier 3 has huge data resolution, which is not readily available in most cases. So our analysis used Tier 1 and Tier 2 methods. We used what you're all familiar with, National Ag Statistics Service, Census of Ag, lime and fertilizer sales, annual compliance reports, notices of intent from the state, and personal communication, as well as literature. Remember, there are 3 greenhouse gases in agriculture: carbon dioxide, methane, and nitrous oxide. I'm going to just skip through that, but this is very important because they're interacting, and we need to think about all 3 greenhouse gases at the same time, in part because they have different potencies. And New York State's Climate Leadership Act requires that we use the global warming potential of 20 years. And you'll see that that means that 1 ton of carbon dioxide or 1 ton of methane is worth 84 tons of carbon dioxide. 1 ton of nitrous oxide is equal to 264 tons of carbon dioxide, right? So small changes across these different gases add up quite differently, right? You can't just think about the mass of the gas. You have to think about the mass of the gas times the global warming potential. We did not include farm energy. That's counted in the energy sector. We did not include the farm woodlands. They're accounted in the forest-only assessment. Wetlands are counted separately. And we do not include emissions from imported food, feed, fiber, or other inputs like fertilizers or tractors, right? So there's some upstream things that are not included. Notably, in the Climate Leadership Act, upstream fossil fuel emissions are counted in the state, right? Okay, I'm going to show you 3 different ways of looking at our inventory results from 1990 to 2020, right? Everybody sees differently. This is the table format, and you can see on the left-hand side the 1990 emissions and the 2020 emissions broken down by gas, activity, and the total using the global warming potential. So you can see that in 1990, we were emitting around 16 million metric tons of CO2 equivalents. And in 2020, we were emitting around 23 million metric tons. Framing it differently, if we think about it in terms of the total, right, you can see agriculture is 6% and energy is 77%. And then here they are as a time course. The blue is methane from livestock systems. The green and the striped is from nitrous oxide emissions. And the brown, yellow, and orange are CO2 emissions from field activities. So the take-home message is just from the inventory portion. Ag emissions are a small fraction of our total emissions in the state. Most of our emissions are coming from livestock, and most of those emissions are from methane. For the cropping systems, right, if you're thinking about mitigating there, thinking about the nitrous oxide emissions are important. Soil carbon changes are a very small fraction of emissions, and most are coming from histosols or the highly organic drained muck soils. There are some ag-related emissions counted elsewhere, such as farm energy use and fertilizer manufacturing, right? There are many possible improvements to these inventories, but they're not going to likely change the overall conclusions. If we were to use a higher tier method, it would be significantly more costly. And at least from our perspective, we think the time and energy and resources would be better spent on measurement and permanence ideas versus inventory detail. Okay, so.
Can I just ask a question before you proceed? Because you mentioned that it doesn't include the imported materials. So like fertilizer is all, nitrogen fertilizer is all imported, right? We don't really manufacture it here within the state. Does that, how do you account for that? Because you still end up, nitrous oxide is still significant.
Okay.
You can explain that a little bit more before we proceed.
Okay, so the CLCPA set the boundaries at the state, with the exception of imported fuels. And that includes imported electricity, right? In terms of its accounting structure. New York did not, I would say that more significant than the imported nitrogen fertilizer would be the imported food into the state. That's not even remotely counted here. So there's just a limit to how you bound the system, and this is how the New York State CLCPA defined it. Do you want to say something, Peter?
Yeah, I'll just chime in. So another way to look at this is, is that those kinds of emissions would be counted in a national or a global inventory, right? So again, the IPCC accounting rules saying there's a focus on counting things where the emissions occur, essentially.
So, because
fertilizer manufacturing would be accounted for where that is occurring.
right, but the land application, you would account for the land application
Yes.
component.
Yes.
in your analysis.
Yes.
Yes.
Okay. Okay.
Just not the upstream, not the manufacturing emissions
Okay.
or the transport emissions into the state.
Okay. Okay. Thanks for clarifying. Yeah.
And there's not a right and a wrong about these boundaries, right? It's a way to make sure you're not, it can help you avoid the overcounting or double counting.
Because I mean, nationally, nitrous oxide is 49%. So we're really, so that's why I was wondering why
Sure.
it's so low. I guess it's maybe just the structure.
Well, a quick thing is just, we got a lot of cows here.
Yeah.
Right? And we have some crops, and other states have lots and lots of crops and almost no cows. So.
Great. Thanks for taking the time.
Okay, I'm going to move on to the high mitigation scenario. So I'm not going to talk about these, right? But we can mitigate within the livestock. We can mitigate across the crops. We can mitigate with woodlands. We can activate so-called idle or underutilized lands, and we can conserve, right? These are the major categories in which we can act, and you'll see the gases that are dominant on the right-hand side. But what constitutes a good mitigation practice? Like if I hold my breath, is that significant mitigation? I'm kind of joking, but I'm also kind of serious because there's lots of practices that turn over. And if we're going to deal with something at the time scale that climate change requires, we need to think about what is a permanent and net greenhouse gas mitigation strategy. And, you know, about 15 years ago, I was in a bar having a cocktail with friends, and the person next to me asked me what I did. And I said, I'm a greenhouse gas accountant. He's like, you do accounting at greenhouses? I'm like, well, one very big greenhouse, right? And I never actually thought of myself as a biologist that I would ever become an accountant. But if we're going to deal with this, we really have to become real accountants, because there's all kinds of ways, forgive me, for being fraudulent about this very serious situation that we find ourselves in. And what I think is so brilliant, our state, I love our state. Our state is great. In this Climate Leadership and Community Protection Act, which we often call the CLCPA or the Climate Act, it has many mandates. It mandates that it should not result in a net increase of co-pollutants, right? So if you're going to fix greenhouse gases, you can't harm water quality, right? If you're going to fix greenhouse gases, you can't harm animal well-being, right? Like you've got to think about co-pollutants. We need to minimize costs and maximize the total benefit to New York State and encourage early action to reduce these greenhouse gas emissions. And in particular, New York State set a social cost of carbon, or the value of carbon, to be $130 per metric ton. So that means for every ton that's emitted in 2025, a mitigation strategy that's less than $130 a metric ton is going to save future New Yorkers the strife and the infrastructure repair, et cetera, from future climate crises, right? And so they also set this at $180 a metric ton in 2050, right? So this is just trying to think about contemporary New Yorkers and future New Yorkers, and what is the financial responsibility of current New Yorkers for the benefit of future New Yorkers, and what we can do to avoid those damages. They mandate that these be legally enforceable, with the exception that agricultural emissions from livestock. So there's only one exception in this whole mandate, right, for the electricity sector, for the transportation sector, for the home building sector. There's one exception for livestock. And I personally think this is beautiful because livestock are living beings, right? We can't treat them like machines like we can treat other things, right? That doesn't mean we aren't responsible for net neutrality at the state level. It just means that it's not necessarily legally enforceable for the livestock. Another thing that I so appreciate being in this law is that we ensure that the greenhouse gas emissions reductions achieved are real, permanent, quantifiable, verifiable, and enforceable. These words merit a whole lecture in themselves. They seem like they're simple words, but in order for us to actually reduce the net emissions in the global total, these terms are incredibly important, and they are in our state mandate. So in summary, the CLCPA guidance of mitigation opportunities suggests no co-pollutants from a change in practice. We need to consider the costs of current New Yorkers and also the costs of future New Yorkers. And we need to ensure that taxpayer money delivers real mitigation by ensuring that these mitigation strategies are real, permanent, quantifiable, and verifiable. So one of the things we did was we developed the SMART decision matrix, right? It has 5 components where the services refer to the co-benefits from the change in practice. So if you do this greenhouse gas mitigation, you also have a co-benefit of improving water quality. The M refers to measurable, which is the quantity of mitigation and the degree to which it is verifiable. Achievable is a low, medium, or high price, where the high price is set at the 2050 social cost of carbon at $180 per metric ton. Realistic is how feasible is it to implement, both in terms of social, technical, right, cultural concepts. And the time frame is the time scale of the mitigation, with reference also to the permanence of that mitigation. So there's a direct connection between the SMART matrix and the CLCPA mandate, right? The services address the co-pollutants. The measurable talks about the quantifiable and verifiable components of the CLCPA. Achievable refers to the cost to society and the value of the carbon to future generations. Realistic assesses if early action is plausible, like can we get on it? And the time frame addresses the permanence. So here's an example of our SMART decision matrix just for the reforestation, right? We identified that 1.7 million metric tons of CO2 equivalents could be reduced by planting trees on over 1.6 million acres, or 600,000 hectares. It's more than that, but with a medium cost, with potential for both short and long-term financial value from these trees. They have the co-benefits of adaptation to climate change and increased biodiversity. And it is important and feasible, but this is incredibly ambitious, right? There's a whole supply chain that needs to be built out, right? We have to think about deer, we have to think about invasives, right? There's all kinds of things to be considered here, but we consider it to be ambitious and realistic, and that it is permanent. In principle, planting the trees is permanent mitigation. In practice, it might be conditional, right? If it's grazed by deer, or if there's a fire, right? But in principle, this is a permanent on a 100-year timescale practice. So this is how we're connecting our mitigation strategies with the CLCPA, and also for landowners to think about what they might like to do and what are the costs and benefits of doing so. So we evaluated 17 opportunities, and in total, they resulted in 12.4 million metric tons of CO2 reduction, right? 3 million metric tons comes from dairy herd management, 5 comes from dairy manure management, 2.5 come from tree planting, and 1.5 come from improved field system management, right? And when we use a negative number, we mean a net removal from the atmosphere. So again, this is the slide you've already seen, right? But this is where we think we can get to with these 17 practices by 2050. And for time, I'm just going to skip through these because these are the 17 different practices, right? That are used for the future scenario analysis. So here you can see the 1990 and the 2020 emissions, right, from our original inventory report. And here you can see the business as usual, the medium, and the high scenario emissions. And you'll see the business as usual is more than 26 million metric tons, right? In 2020, we were at 23 million metric tons, right? So we're increasing if we don't do something, if we don't have policies to reduce emissions. In the high scenario, we think we can get down to over 10 million metric tons of greenhouse gases, right? And you can see that this is less than the 1990 level. So to sort of summarize the data so far, if all the current activity and efficiency trends continued into the future, for the business as usual, we estimate an increase of emissions in 2050 to 26.7 million metric tons of CO2 equivalents. This is a 62% increase in 1990 emissions, and this is a 16% increase in 2020 emissions, okay? So the purpose of the BAU was to estimate changes in agriculture and associated greenhouse gas emissions expected to occur in the future without climate-focused policy, funding, and programs. This allows us then to compare with our other scenarios where we advocate for different practices. In all of these scenarios, current agricultural and forest land is assumed to remain constant, and recent trends in agricultural management are assumed to continue. So this is the business as usual scenario in this format going, so this is 1990 to 2020, and then here is what happens in 2050. Right, we have growth. We have different kinds of growth, and we don't have forms of sequestration, aggressive forms of sequestration or mitigation. I'm going to skip that, and I'm going to skip this. Okay. In contrast to the business as usual, the high scenario assumption is a highly ambitious degree of implementing mitigation strategies. It often approaches the technical potential. It requires a very large state-led effort, requiring a great deal of financial and personnel resources. It requires a high degree of changes in land management by current practices and requires a high degree of intensification of current management practices beyond what is common in the state. In the high mitigation scenario, we estimate that we would be emitting 10.6 million metric tons in 2050. And you can see where 2020, right? This is basically where the analysis pivots from the inventory to the future scenarios. You can see the ways in which these are reduced in the high mitigation scenario. Notably, there's a significant increase in the sequestration by reforestation, and this graph continues into the future, into 2017, before it sort of plateaus. Okay, but you can see that this is a significant benefit, but it has a longer time scale than where we stop our analysis in 2050. And you can see that most of the reduction is achieved from the manure management and some from the enteric management. I'm going to skip this chart because it's... So, in comparison between the medium scenario and the business as usual, there's a 41% reduction, right? And then the high scenario, there's a 60% reduction from the BAU, right? But the legislation doesn't care about what the future business as usual looks like. The legislation wants us all to be net neutral by 2050. In the high scenario, it is only a 35% reduction from the 1990 levels. And that includes a significant portion of afforestation happening on our former agricultural lands. So just to recap, the CLCPA goal for 2050 is that all sectors reduce emissions 85% below 1990 levels and are net neutral by 2050. And the high scenario only got us 35% below 1990 levels and includes significant sequestration. This is kind of redundant. There are several significant assumptions, right? Where afforestation or reforestation happens on over 662,000 hectares. Which is conversion of former agricultural land to forest and conversion of current pasture land to civil pasture. It assumes milk production is held constant at 2020 levels. This is a significant assumption. And all the efficiencies that are gained by the cows are what causes the reduction in emissions. It assumes high management by all farm types and practices, and it does not achieve the 85% reduction in ag sector emissions. It is extremely ambitious to implement. It will take significant effort to achieve by landowners to change the land management and also to intensify the practices. It will take substantial financial, supply chain, and personnel resources. I want to just, Peter worked on a really great project. And I want to feature it because it helps us think about the importance of net greenhouse gas accounting. So we all know in this room that carbon and nitrogen have complex interactions in the soil. And we also know that in New York State, 1 pound of nitrous oxide lost from the soil negates 264 pounds of carbon dioxide sequestered, right? So a small change in nitrous oxide can negate a huge amount of carbon sequestration. So we need to think about the net impacts, and we must consider all the parts that go into the system's change. So the following two examples illustrate the complexity for arriving at what we call net greenhouse gas benefit. And this should also help a viewer understand or consider what might go into verifying the validity of an activity for long-term greenhouse gas mitigation. Not in these next slides is an important detail, which is, remember when we reduce nitrous oxide, it is permanent. But if we increase soil organic carbon, it's easily reversible, right? So there's another whole element to what's happening in the next slide. So I highly recommend folks look at Peter and others' FAST GHG model, supported by Atkinson and others. So this is just an example, right? There are all different kinds of examples, but no-till reduces net greenhouse gas emissions through a combination of reduced on-farm fuel use and a small increase of soil organic carbon, right? So you can see here's the soil organic carbon and the reduced fuel used. You still have your nitrogen fertilizer productions and your N2O emissions, but your net is over here. Using the same model, a non-legume cover crop increases net greenhouse gas emissions because more nitrogen fertilizer is needed, increasing the N2O emissions, inputs, and fuel, and these emissions exceed the benefit of the increased soil carbon. So this is what we mean by net greenhouse gas accounting, right? Just because you change a practice does not mean that you're mitigating your net greenhouse gases, right? And we also have to remember that this is a highly reversible mitigation component, right? So it's not for sure in terms of our timescale that we're thinking about. Okay, just to summarize, and then we can open it up for questions. The most ambitious agricultural sector scenario achieved a 35% reduction below the 1990 levels by 2050. Meanwhile, the state's goal was that all sectors be net neutral by 2050. Any change in practice must be a net benefit over the old practice, and we need to assess simultaneously the flux of CO2, CH4, and N2O together. And we also need to assess the upstream and downstream impacts from these changes in practice. We promote strongly practices that demonstrate permanent mitigation, right? There are all kinds of reasons to do all kinds of things, right? But if we have limited funds, let's do the practices that cause permanent mitigation, right? So that we can know that we're bringing down the global total. I think one of the most important things I would like folks to walk away with is that natural climate solutions might not be a realistic net mitigating sink for other sectors, right? Everybody talks about natural climate solutions as being a solution for solving all of our problems. But as we've demonstrated today, we only foresee a 35% reduction in 1990 levels, and that's with a significant amount of afforestation occurring on 1.6 million acres in the state. So, given that, we all in this room, even though we're in the soil and crop sciences department, need to think about our social use of fossil fuel for heating, transportation, and electricity. Because again, I just want us to remember that this is where the majority of the problem is, right? And this is the ag sector emissions. I'm not saying we aren't responsible for taking care of this, but all of us participate in this component, and this needs to come down also. There are all kinds of next steps, some future research needs. We all need better data collection. We needed an accounting framework to assess how a change in practice and the implementation works out for the net. We need clear guidance on real mitigation across practices. We need to develop measuring, monitoring, reporting, and verification logic and rules. We need to work on landowner change and practice studies. We need to think about supply chain and workforce build out, from tree seedlings to ag engineers. We need to think about food waste reduction, both pre-consumer and consumer, right? Because every amount of food that we do not waste is all these acres and all of these associated emissions. We need to think about the highest and best use of our finite agricultural land. This is one of my pet peeves about why we don't count the imported food and feed to the state, right? Because the compromises we might make on our own agricultural land mean that the emissions for our food production are happening elsewhere, and we have no stewardship over how those are managed, right? So as a result, we do have to think about the highest and best use of our finite agricultural land because it actually is quite special. We all know that, but I think society at large is so accustomed to food consumption coming from anywhere that we have lost that touch. And we also definitely need to think about our electrical grid to reduce conversion of farmland to solar energy. Okay, there are loads of folks to acknowledge, but in particular, this work was hosted by the New York State Department of Environmental Conservation, but we also had a NEFA project, an Ag and Markets project, a NYSERDA project, and Atkinson Foundation funding. And we would like to give special thanks to our technical advisor group, John Duxbury, Tim Fahey, Kristen Foster Reed, and Michael Rowan. I think that is it. Yes. Questions?
Jenny,
Yes, John?
do you have any reaction from DEC about your work? I mean, what I'm thinking is that politicians don't like complexity, and you're bringing in a lot of thoughtful things that they might rather ignore as politicians.
I have to say that the CLCPA legislation, which is a political maneuver, right? It's a ruling, is really smart and well-defined structure for the state, right? And DEC works within that structure, and DEC Office of Climate has been I feel that the DEC is bound to all of society, but they follow the mandate. And I think that they are genuinely engaged in the real permanent and verifiability. And then I think that what happens after DEC and how money gets allocated is a whole nother matter. So I think DEC is a really great, Office of Climate is doing a really good job of trying to hold the course for real mitigation. And you know, they have a responsibility to have real mitigation happen, right? All of these projects will be funded by basically taxpayer money in a certain way. And maybe not all of them, but a large number of them. And I feel like they're doing a really great job of holding the space, right? Like, how much methane goes into the atmosphere? That's how much methane goes into the atmosphere. If you don't count it correctly, right, you're not mitigating it. So I think that there's a way in which they're genuinely holding the course. That said, I think funding allocation and subsequent decision-making has a lot of cultural pressure.
Jenny, can I just add a kind of an important footnote to that to be specific? So this analysis provided the official greenhouse gas inventory for New York State for 3 years. Subsequent to that, we turned over our big messy calculation system to DEC, and they are producing subsequent years of official inventory using our analysis. So it's now embedded in their process. So that's a sort of a literal uptake of our work. It's not just a report sitting on a shelf.
So hi, Jenny. Thank you for that nice talk. I found it really interesting, and you might guess my question. How does biochar figure into this climate greenhouse gas emission reduction? Do you have it anywhere, or is it so small that it does not count yet?
So we do have it. Oops.
We have one project with NYSERDA where we put a kiln onto a dairy farm, Spruce Haven to pyrolyze cow manure, basically, and then put it out onto the field.
So it is one of our practices that we feature, and it reduces 0.03 million metric tons using only the sustainably harvested residue from croplands, right? We could also convert forest biomass into biochar. That would be another thing, but this is where this falls in this assessment.
So just crop residues you are figuring.
Sustainable crop residue. Peter, do you want to say more on that?
Yeah, so this is from national analysis called the Billion Ton Study, which looks at what is the potential feedstock production for bioenergy of all kinds. So based on that analysis for New York State, there's a calculation of how much crop residue is produced. Obviously, that crop residue has many values. You want to return a substantial portion to the soil, but some of it could be harvested, and that's the amount of material that we looked at. So this is a good example of where there are lots of assumptions and decisions to be made, and also just because we included that aspect of biochar, using biochar in some other way, like if you can use it to mitigate emissions of something else like manure, that we did not include. So there is, overall, I would say there is plenty of room to revisit the choices we made about what we analyzed, as well as thinking about other practices where there might be good evidence that it could become, could be scaled up. So not at all the final answer here.
Well, you're talking about that. So thanks, Jenny. This is really fascinating. It's nice to see the numbers on these things. So you mentioned it in one of your last slides about the final bullet point, and it's solar. Solar, to me, solar is also an agricultural practice. It's just that you're using different materials. But solar could change some of these other factors in a big way. I mean, if it's, for example, reforestation, if we say, well, we focus more on solarization of land, of course, it bleeds into your big blue bar, which is the energy consumption. But have you looked at solar? And there's also a relationship with corn ethanol, if we're starting to look at different energy sources. What do you think are the options there?
Okay, so Ted, our colleague, has been working, he's left. He's out in the field.
So where are the costs?
This is also included in our analysis, are the historic trends of solar on agricultural land into the future, and how many acres would be considered taken out of production and into solar production. I agree, it is an agricultural product, but we also have idle land that isn't high quality soil, right? That isn't currently producing other things that could be making money for that local community while also producing potatoes on the original land. This is my perspective, considering how much food we import into New York State. That being said, Peter, do you want to make a comment on the solar analysis? And I'll try to find the actual numbers.
Yeah, again, just sort of an addition to what Jenny said. So we projected to meet CLCPA solar goals, we projected how much land will be required by 2050. And we subtracted that area from the land that would otherwise could be available for reforestation. So that's kind of the nuts and bolts there. We did assume that the total amount of cropland would be the same in the future. So plenty of room to think about land quality and which lands are being used for solar, which are being used for agricultural production. And that was kind of that last bullet point of Jenny's, that in general, as you know, a lot of current cropland is being converted to solar because it tends to be flat. The rocks have been dealt with. There's no tree stumps to remove. There's et cetera, right? All the reasons that make it good cropland make it good for solar development. So I think we think there's room for prioritizing extensions to the grid so that solar could be built primarily on former ag land of lower soil quality and lower suitability for agriculture. And again, that'd be a nice PhD dissertation right there, right?
Yeah, no, absolutely, yeah.
So these are the numbers from Peter and Ted's work on what was anticipated to be taken out for solar and wind.
Just have one quick comment on solar. I don't understand why it's not being installed on parking lots. For example, here at Cornell, at the malls. Is it more expensive?
The short answer is money. It's much more expensive. So it's much less expensive to install a big facility on open land.
I saw it at an IKEA in Beltsville, Maryland, towards USDA. They have the solar panels there, and it's really getting hot there, and summer's really nice. So they give shade, they produce energy. So it's
The scale of what needs to happen is very large.
okay.
But I want to share, I just put this in because I was astounded when I read this. So in China, in the month of May, they installed 93 gigawatts of solar capacity. Now, that doesn't mean it's actually producing, but that's 100 solar panels every second. And since January, they have added 198, that's supposed to be gigawatts of solar, which is almost the entire fleet. So 5 months, right? But look at this, right? Like, there are real considerations. And then just to give you some context, right? China's GDP is 10 trillion, the US GDP is 30 trillion, and New York State's GDP is 2 trillion. Like, there are certainly ways in which I feel that our state could do a great job on thinking about this. And China is making other kinds of decisions than we are currently making, whether or not it's a parking lot or something like this, right? I just wanted to put that in there. Any other comments before we derail?
I'm afraid that we are at time. Thank you again. Let's thank Jenny one more time, folks.
This has been a production of Cornell University, on the web at cornell.edu.